Yes, so I hope you all see my screen now, and maybe we can make this full screen for the audience as well. So, but like I think it also works like this. So maybe just a little bit because I am now, if you look into the agenda here, or like let me quickly figure it out here. Like there's like kind of multiple sessions planned for this introduction into matRad and also doing hands-on stuff. So everybody that's online or that is here and has a laptop um, with a little bit of RAM and maybe not one of the newer MacBooks, we are a little bit limited on what we can run. But everybody who wants to basically can try to install it and can try to run it and do some hands-on planning. I will show everything that I do interactively here and explain what I'm doing and give some time to everybody who can do it to play around. Since before we get into setting it up, since Jutta asked me to say a few things about DKFZ and where I'm from. So like the DKFZ in Heidelberg, I'm now on the website here of our department, is at a very large research institute with a lot of biological cancer research. So we have a lot of, for example, immunotherapy groups. You see here our research program, so cell biology, functional genomics, prevention is like one of the big topics that is often overlooked when you hear about cancer research. Everybody wants to do fancy biology or medical physics, but like I think something that has the biggest impact is just to prevent cancer in the first place through lifestyle, for example. Then immunology, we have a big program, and of course the medical physics oriented imaging and radio oncology. Our department is focusing on the physics in radiation oncology, so the therapy side of it. We have like a few other departments looking into imaging or biomedical physics in this research program. And the department is led by Oliver Jeckel, who is at the same time the medical physics head of the Heidelberg Ion Therapy Center. So that's kind of where you see the connection to start to hadron therapy. And that's why we also have some expertise in the algorithms for these type of treatments. Yes. So also like in this department, you find an overview of all the research groups. And basically, if you're interested, for example, in doing some thesis or whatsoever, you can always contact just these group leaders. And we just recently also, for example, had a student from Greece who did an Erasmus internship with us and actually implemented a brachytherapy module for matRad. So there's like something to do, and something that's also very interesting at the DKFZ for students that are maybe at the end of their masters. There's a PhD program where you can get a scholarship. I will make this a bit smaller here. So there are some opportunities which you can apply, I think usually 2 times a year in April and in November. It's a program very open for international students. So it's still competitive, quite competitive, but yeah, this might be interesting, the DKFZ PhD program, you could look it up. Yeah, but in any case, if you're interested in anything, you can always write us. If you want to do some educational course or you want to do some research with matRad, which we come through soon, you can also directly contact me in the end. Okay, so now what we want to do later, starting after the coffee break, is to really do some hands-on planning. And for that, on this whole website of this day's workshop, there was an instructions pane on how to install matRad. So basically this was here. There's some information about the tool. I will talk a little bit about it in a minute. So the main thing is that it is an open source software. At the time when we started to implement this, which was in mid-2010s, MATLAB was still a very big thing, and it's in some institutions still especially for computational medical physics. There were a lot of imaging tools and a lot of courses with MATLAB and so on. So we decided for MATLAB, of course, today, if we would do it again, probably take Python or something like this as a just more accessible language. Because MATLAB is a proprietary programming environment and programming language. So a lot of universities have it. So often when we go to give these courses, a lot of people can install MATLAB because they just get a MATLAB license from the university. If you don't have MATLAB, we also provide an executable that you can use. And that's why there's two pathways in how to install matRad. So I hope a lot of you online have done this already. Otherwise, you can try to do this now. You just follow these steps here. There are two steps. If you have MATLAB, you can basically just download our code and then run it within MATLAB. If you don't have MATLAB, you can just install a standalone, and there's a video and everything. So if someone has not done this, I will go through this very quickly, but I don't want to basically do this in that detail that the people who have already installed it and prepared very well for this day are now basically on the downside waiting for everything. So basically both of these ways point you to this matRad release. So I can just open it here. And you get to a page on GitHub. For everybody who doesn't know GitHub, GitHub is one of the, or like, I don't look these things up in that detail. So I always say one of these. It might also be the largest, probably is the largest open source code sharing platform. You find everything there from standard open source to very specific or personal repositories and whatsoever. What you see here is release description. Like if you don't have MATLAB, you can now use one of these installers. This is a script for Linux. This is a DMG for Mac. And this is an executable installer for Windows. So if you don't have MATLAB, you download the one for your operating system. And if you are a MATLAB user, you can just download the source code here and extract it to some folder. Doesn't matter where this folder is. So, yes, I have already done this. So I can look this up. It's like somewhere here. So basically, you can just start this installer. It will ask for permissions and it will just run up. I have already installed it, so this will be very fast, but you will be just asked to go through all the steps and so on. Yeah, I will not install it now. There will be a larger download here that you need to run because it needs some MATLAB packages to be downloaded and so on. So this is like really just a normal installation, and you can run it through. If you are a MATLAB user, you extract it to some folder, open MATLAB, and what you see here, like I put the code in some folder, like that's where I put the code into the MATLAB matRad folder. And then you should have all the files here, and you can just start running it. For the ones who have installed it, you should, after the installation, have some form of matRad icon. For example, in the start menu here, you now see matRad. Yeah. And this you can just run, and then after a while, I have all, like I haven't opened it now. So if you run it, you will get kind of a splash screen. The first time can really take a while. And after that, you should get a user interface of that has like our logo and a few widgets that do something, which we will get into. And this is basically a very simplified user interface for a treatment planning system. So this, what you see then, is not clinical, of course, but it has some of the functionality for clinical workflows. If you are not a standalone user, you can also open this user interface. And I will use MATLAB directly just because I want to show and teach a little bit of the computational logic that is in such a treatment planning system. And in MATLAB, I can do this really nicely by showing you data structures that are used in such treatment planning systems. And what you need to do if you have the code to run the graphical user interface, you just need to run matRad GUI. It's basically a file that is somewhere here in our tons of files, like here. You run this command, matRad GUI, it will also open the user interface. So that's about the installation, since some of you might still run the installation. Like your test for it to successful work is that this user interface shows up. If this shows up, you are set to go for the rest of the day. If it does not work on your computer for any reason, you might just follow what I do on the screen. Also for the audience here that doesn't have a laptop or whatsoever and is just interested into the computational aspects of treatment planning, just follow what I do on the screen. There will be some interesting thoughts about the inner workings of such system, about the math behind it and the physics behind it. All right, so you can all do your installations, your downloads or whatsoever over the next 15 minutes. I think there are a few people also helping online. You can also relay the comments to me here, and I will try to ask or answer any questions. Just really quickly, I will give you an overview about this treatment planning system, matRad, so you get a bit of an idea of what you are dealing with before we delve into hands-on planning itself. So let me quickly load a presentation. So matRad is a treatment planning system, and we just had the presentation, which is very nice that this presentation was scheduled, so I do not need to talk too much about how to set up the geometry of patients and so on anymore. So what do? We go from some image. So we have an image of a patient. This is a CT. It doesn't really have a very good window setting. There's a question. Let's check it out. If one has MATLAB software already installed, I will soon repeat it. This is very fast. Let me just quickly show you again. Basically, you just follow what's in this agenda thing. So what you do is the following. Here you have this first way, source code to use within MATLAB installation. You go to the link given here and you download the zip file. So just very quickly, you go here to this link, you download the source code zip. You put the source code in some folder, you run MATLAB. I already started MATLAB, so you just start MATLAB how you would start MATLAB, and then you go to the folder where you put your source code. Like, that's the instructions I will give. The rest is also well described on the agenda website. So let's go back to this. So what we do is basically we go from an image to a dose. Like, that's kind of the problem we solve. We start at the point, I think the speaker before talked about also about we need to contour and everything. We need to set up the geometry. For what we do now, where we want to learn how does actually this shaping of the dose work, we basically have already an image that is lined up, has its contours drawn. So here it's kind of what you see. You see a contour of the patient like this. You see, oops, like maybe let's switch to the pointer here. You see targets. So we have here kind of a CTV, like a primary PTV already outlined. The CTV and the GTV are no longer shown, and a lower dose PTV and also an organ at risk. And based on this, we want to figure out how to get to the dose that might treat this patient well enough. All right. And for this,
there is a question in the chat in the Zoom, which says, can you repeat how to install matRad if one has MATLAB software already installed?
I already answered this
I'm so sorry.
just a few seconds ago, but it's good if you basically tell me the questions, then I do not need to click around here. That's a good thing. All right. So, and for this we need, this is basically this is a task solved on the computer. Yeah, that wasn't always the case. Like we also did radiotherapy before we had computers. It was a little bit, sometimes when you think about how this was done before, it's a little bit frightening, I would have to say. But actually, it was the case that directly a few years after discovering X-rays, like in the beginning of the 20th century, we started to realize that this is like can do harm to tissue, and started treating patients. Yeah, and then it came that you really got like just some geometry on a piece of paper and try to draw in where the dose might be and kind of and so on. So today we do all of this with computers, and so you need a lot of knowledge and code to basically implement a simulation of dose. So we heard about this different dose calculation algorithms and so on. And that's kind of the primary functionality. We want to provide these tools, these kind of codes for open research, and so that students can also look into it and learn how dose calculation works, for example. So we have a bunch of users. So I think on GitHub, there's 180 forks around now, which means 180 people have kind of taken our code, put it in a separate repository and continued development for their research projects. It doesn't tell us how many people are using it in reality, but it's like some number. This map is a little bit outdated. But I think right now, or like 2 years ago or last year, there was like the first users also in Africa popped up. So we are now on kind of almost every continent except for the one down here, which you don't see. I guess we will never get a user here, but might be fun. And there's also a paper you can read. You will find it on our repository if you're interested in the technical details behind it, which is quite heavily cited and also gives some estimate of the amount of research projects done with the software. You also have a lot of documentation. So if you really want to go into research or do something more with it, I have to say it's the problem of any research software. We are always behind on documentation. Yeah, it's like we are happy if we can implement something new and exciting for the people, and then we forget to document it nicely, or the documentation is from 3 years ago and stuff like this. But you find some explanations about how does the data look like and so on and so on. And of course, you can always on GitHub just write any problems or questions that you have, and we try to answer it as soon as possible. So what we want to do with this tool is to give people 2 ways of working with this in any kind of way they want. So on the one hand, you have basically a graphical user interface that leads you through the workflow, and you can script your way through the workflow. We will not script today because that's a little bit demands maybe a lot to get everybody just to write some scripts. But in principle, you can, for example, load and import your patient per script, then set all the plan parameters in the graphical user interface, run a specific dose calculation per script, optimize your plan and go to analysis in the graphical user interface. So that's kind of the philosophy of matRad, so which allows you to do kind of this research and educational environment and combine those quite nicely, because you can actually modify every step of the workflow. Of course, for a clinical environment, that's something that probably would be nice, but regulators would kind of scream in agony if they see you modify the source code or whatsoever and do whatever you want. So of course, that's one of the reasons why this is not a clinical system, because if the users can change everything, then it's very difficult to regulate this. Yeah. So if you really want to write nice regulated code that basically registers as a medical device, like there's a nice EU regulation for all of this, then you basically have to jump through additional hoops, and that's not kind of makes the software then also non-research friendly in the end. Yeah. As said, this is kind of how it looks like, and we will see this in detail, I think, later after the coffee break. Good. One thing that we can do, which is kind of unique, I would say, for matRad, there are some other tools out there that can do parts of it. So you can do dose calculation and inverse planning. So you always, for treatment planning, you need two things. You need a dose calculation algorithm, like just from the computational side, you always need a good medical physicist. But from the computational side, you need a dose calculation algorithm that can simulate dose, like dose is energy deposited in mass, right? In principle, for the physicist or mathematical oriented problem, you need to solve the radiation transport equation. Fortunately, there's some simplified ways to do that for our purposes. The most accurate and most extensive ways are to solve this equation by doing Monte Carlo simulations. Monte Carlo is also a way to solve a integral differential equation. Or you basically solve the equation with other mathematical methods, like I think you mentioned the Acuros solver, which basically does radiation transport by solving the differential equation directly with some tools you also know for differential equation solving maybe. And or you can use parametrized analytical algorithms like pencil beam, convolution, AAA, whatsoever. And so this is the dose calculation algorithm, but when you have a dose calculation algorithm, you can just calculate dose, but you have no idea what the machine should do to shape a nice dose. And then that's when optimization comes in. So when you know the dose, you need an algorithm that kind of is able to shape this dose in a way and kind of configure the machine to give you like something that covers only the targets instead of, like, for example, here where you don't have any idea, so you would just blast the patient with dose. So you need an algorithm that kind of finds a way to shape a conformal dose distribution, how we say it. And we will look a little bit how these two steps interact in our sessions. Yeah, then that's just one thing. matRad is validated against clinical algorithms. So we do, like, what you see is realistic in a sense, not from the clinical planning perspective, but the doses are realistic that you see. And yeah, this is a little bit about why MATLAB, but I will not go into detail here. Here's a little bit of features. So you can import DICOM images, you can run multiple modalities, photons, protons, carbon ions. In the next release that is coming, not the one we are using today, you could also do helium if you want to do it. And so on and so on. Our algorithms that we use today are all analytical pencil beam algorithms. That's just because of the computational needs. Yeah. So of course you could run a Monte Carlo algorithm, but we heard before Monte Carlo can be agonizing slow, and especially when you lose open source software, you use maybe GN4 to simulate. It's like really a long time to wait for ions. So we use analytical dose calculation. You can do a lot of optimization with different objectives. We will go into that. Biological optimization. In the new versions, you then could also do robust optimization and 4D planning. And the nice thing is that you can basically combine this as ever you want. If you're a little bit fit in scripting, you can do whatever you want. You can do a 4D robust photon treatment plan. And we have, for example, research projects where we mix carbon ions and photons or stuff like this. So like anything is possible with such a tool. And that's the primary thing for research for matRad, is that you can do weird stuff that like a regulated treatment planning system will never implement and the vendor will never implement because it's not yet commercially viable. Nobody has tested it. It hasn't gone through the preclinical phase yet, so they will not implement it. Okay, so that is my short introduction into matRad. I think in the schedule, we now have a coffee break. Let's quickly go back to the schedule.
We have a question in chat if you want. There's a question about the Helium update. When might be the next release with the Helium update?
Like there are already some people very eager to try something up, for example, like the Heliums. I can show you something. So if you are on the GitHub, like this is our GitHub page, and like you see this, like we had for a long time, we didn't have a new release. There is something like a funding hell in research. So we had funding to create the software. It was created, and then it took a while to get the next funding. So there was like a phase of 2 years now where we didn't really have a release, but a lot of research. And now we had some funding to get this back together, like had some dedicated postdoc. And basically here, you kind of see that we are in the final preparations, like just 4 days ago. This is basically that we are going for the next release, and this can do all of the new things that I just said. I can show at the end of this day a little bit, maybe go into a helium treatment or do some robust optimization. You won't be able to do it then, but it could be just the last half hour. I give you a little bit of an insight of some of these things. Because especially robust optimization. So if you go on the matRad repository, which basically, if you were at this release page before, like we started at this page, you can just go onto pull requests, click here. And this is basically the code exactly for the stuff with all the helium and whatsoever in it. So you can basically just from this pull request, go to the code directly, download this and use this. I would not advise you to do this today because it looks different. The new matRad looks different, has a lot of more buttons to configure the plan as well. So I would stick with the older version for today, but later we can check it out a bit. Okay. Yes, LAT optimization, about this, like you see there's already here like another contribution by by a student, by Lisa. She was a very talented bachelor student in our group. And she implemented LAT optimization. This will not be in the next release because we want to change a lot in optimization in general and do this in the next work, but you can always check out what these people did. The nice thing about GitHub is, so if you go on GitHub and you look onto what's going on, like the whole development is transparent. Yeah. So basically this contribution from Lisa is already public and she has it on her fork. So you can just go here, download her code, and try it out. So you can always follow a little bit what's happening here and try to use it. And yeah, these things find their way slowly into matRad, but steadily. All right. Any other questions?
No, we're good. We can go for a coffee break and we will be back at 11:30. Thanks a lot. So Niklas, the floor is yours again.
Yes. So welcome back. I hope everybody had a nice coffee break. I still see some people coming in, so I need a few seconds anyways to share my screen again. So maybe for the online participants with regards to questions, as she just said, they will forward it to me, so you can ask questions. But I just want to say, we are now working with a research software that we develop. We are not like a software development company that has 20 people working on user experience alone, and we are kind of a few people that try to keep this running. So not everything will work. Yeah, so you might be able, users are very good in doing things and breaking applications in ways that you cannot imagine. So you will end up triggering some error. You will run out of memory because treatment planning itself is a kind of memory intense task. Maybe the program will not run because there is some incompatibility on your system. Maybe it will break at some point. So it is unlikely that we can resolve these questions like here. And if we do, or if I try to do this while I'm presenting, like I will sit here 15 minutes trying with individual people to get it running. So this doesn't make sense. So if there's like bigger problems, these questions I cannot answer now. Maybe someone is able to help you, but it's usually like this, every problem that is unusual for us, and all of the problems that are common we have already seen and try to fix them, but every unusual problem that comes from users also takes an unusual amount of time to fix. So it really doesn't make sense to try to do this here. Then I would rather recommend you to just follow what's happening on the screen and try to do the rest in after the workshop. Because you can just download the software. If we manage to fix the problem afterwards, you can just do the stuff. You don't need us, or the software will still be there for you, free to use. That's about the questions. I'm very happy to answer quick questions about like some like scientific aspect or some educational aspect, like why are we doing this, or could we do this instead? Like this is, I think, the stuff that I can answer, and that will also be interesting for everybody else. So these questions will be then also forwarded to me. Of course, for the audience on site, I think you can just use these microphones and start interrupting me. It's not that big of an issue to me if I get interrupted by an interesting question. So also a dumb question is fine. Yeah, there are no dumb questions. So yeah, just feel free to answer, to ask anything you're interested in and what you see.